Okay guys, we are back with another video on the LCD display, and this time we've just made a small addition to the circuit to include an analog input. Okay, so what I'm going to do, we'll just quickly look at the circuit diagram. Okay, so this is something very similar to what we've seen in previous videos, so I'm not going to spend too much time going through it. It's, as we said, pretty much the same standard setup for the LCD with the additional power supply, but what I'm doing is I'm simulating an analog input. So we've got a potentiometer here, we're just connecting it the same way we've seen before in another video on our potentiometer. We're just giving it 3.3 volts, giving it a ground supply, and then the middle wire, or the middle connection, we're taking as our analog input. And what we can do is we can manually change this potentiometer, we can turn it, which essentially changes the voltage coming into that pin, which is like an analog signal. So we've done a video on the analog input before as well, and we've done a video on the setup of the LCD, so I'm not going to spend too much time discussing that again. It's the same circuit diagram, same sort of setup, and things like that. So I'm going to hopefully just breeze over that and go in to the video setup what we have here. So it's the same thing, just turned upside down so we can read the LCD display. Okay. Now the whole purpose of this setup is I want the LCD display to display the values of the current value of the potentiometer at any moment in time. Okay. Oh, sorry. So what I can see there is, okay, I've just wired up my potentiometer. Now, when I start the MBED again, we've just got a small welcome message, and then we've got a reading for the voltage on the potentiometer. And as I turn that potentiometer, as I change the analog value, you can see my LCD is updating close to real time. Now, what it's actually doing is a 2-second delay before it'll check for a new value of voltage. So you can see that's it there. Now, what we tend to do with a lot of analog devices, we have a multimeter here to verify if it's correct. Now you might not have a multimeter at home, that's fair enough, but just to show you and to prove that some of our calculations within the MBED are correct, what I'm going to do here is I'm just connecting my multimeter in, I've set it up to read voltage, and I'll take ground supply and I'll just read in, and I'm trying to squeeze it in there on the analog pin. Okay, it doesn't matter what side you go in at the potentiometer, just once you're in that middle pin. So we can see there, look, our LCD is matching up with what we're seeing from the multimeter. As I change it, you can see the two of them are lining up. Now obviously the multimeter is going to be the most correct, most accurate. There's a wee bit of a delay with the LCD display, because remember it's only checking it every 2 seconds for a new value. But it's quite nice and it's quite accurate there of what we're getting. So we tend to see that a bit with analog devices that we'll try to maybe calibrate them or just verify that our calculations are correct through some of these devices. So it's useful to be able to do that. So I'm hoping the wiring isn't too bad. You get the concept. We're just changing this analog input here. We're manually able to change it. It's giving us in different voltages. The MBED's running a calculation, and then it's displaying that in roughly real time onto the LCD display. Okay, so quite nice bit of information. And then I just joined in the multimeter there just to verify everything was correct. So I hope that's okay. Really, the most of it comes from the code here. Okay, and I'll actually just look at it in this view if that's okay. So we've got our library files. Okay, we've seen that in other videos as well. We're happy enough with that. And we created our LCD object. So the new thing I really want to focus on is this part here. Okay. So in the lectures, we're going to spend a little bit of time on data types. So what does this float mean, and actually what does this int mean? We've seen that quite a bit before, but we've never really discussed it at this moment in time. So we should be happy enough. We've used the analog input before, and we're just calling this a potentiometer connected in pin 15. But what I have is I've actually got 2 floats. So these are data types, and basically a float tells us what is being stored in this variable. This is just variable name. So we have two variable names there, we called it raw value and voltage. Could have called it anything, but because we're measuring the voltage, that's what I've used. Now they're a float because I'm measuring decimal points. If it was just integer, it would be whole numbers. Okay, so there's different data types, there's a whole range of them, and we'll look at a few of them as we go through some of this material. So we're just creating a storage location that we can store these numbers in, okay? And we know that they're going to be of decimal point value. We go into our main loop and we have a bit of a welcome message. So it just runs through this code, and then what it does is it goes into our while loop. So it'll just constantly loop around this section of the code continuously unless we turned on and off our embed again, and it would give us the welcome message. So you see it's just looping around here, and there's a delay of 2 seconds. So it runs the code, waits 2 seconds, and then loops back around again. And essentially what I want it to do, when it loops back around, I want to check for a new value at the potentiometer, at the analog input. I want to check that new value, see has it changed, and then I want to display it. So let's look into this code. Let's look at a couple of things that we're comfortable with. Okay, yeah, clear the LCD. So each time I'm updating the LCD, I'm clearing it and then printing the same stuff again, but hopefully with a new voltage reading. So we know that command. We know how to print. We know how to move the index of our location, of our cursor, and we know our wait command. So we should be happy enough with those. We've covered them in some videos. So what I would like to look into a little bit further is these commands here. So let's look at this. And this would be quite common when you have an analog input. What you have is, remember that we decimal point the properties of a particular variable. So we're looking at this variable that we called pot for potentiometer, and we're doing a dot read on it. So we're reading the information at that variable. And we know it's analog because we created it. So it allows us to read the value. Okay, and what it actually does a little bit of this thing about resolution and an analog to digital conversion. We're not going to worry about that too much, but we basically read the value at the potentiometer at that point in time, and we store it in here into this memory location. And what we actually call that is we call that the raw value of the sensor. Okay, this potentiometer doesn't actually give us out the voltage. It's just giving us this raw value, depending on the resolution of the analog to digital conversion. It's just giving us out a raw value that the MBED is looking at. Okay. Then what we have to do is we actually have to scale it to make it into a kind of voltage reading. Okay. And what we actually do, very simply, just multiply it by 3.3 because that was the supply voltage that we give the potentiometer. So we're actually scaling the value that we do here. Now, that just may seem maybe obvious, maybe not obvious, but let's just look at it a little bit further, right? We'll see it in some other examples when we go into like a temperature sensor or something like that, but essentially what we do is we read the value at the analog pin on the MBED, and that just gives us like a raw value. Okay, it doesn't make much sense to us at the moment. It's just like take it like a computer value. We'll go into the details a little bit later. But then what we want to do is we want to normalize that into the scale that we're dealing with. We're dealing with a voltage scale, so what we need to do is we need to multiply it by 3.3. Now, if we had a different sensor, you may have a more complicated formula here. And that tends to be what happens when you're dealing with analog inputs. You'll have like a formula that will, convert it into the unit of measurement that you're looking for. So the sort of process with an analog input is you have a raw value, and then you have a formula to convert it into the unit of measurement that you're looking for. Okay, so we've done a little bit of that before, and we'll do a little bit more on it. But if you can keep those ideas in your head, the sensor just reads a raw value, so it's not necessarily the true value or the unit of measurement that we're looking for. And then what we'll do is we'll put that into a formula that will give us that kind of unit of measurement that we're looking for. So that's all it's doing, and that's why we need those storage locations, and that's why we need them there. And we know that it's going to be a decimal point. Well, we're multiplying it by a decimal point, which makes sense as well, but we want to have a bit more precision in it. So the last thing, and probably the most new thing here, is, okay, we're printing some information. And what we're doing is, well, we know when we print, we set up what it's in our quotes, okay? But what we've got here is we actually got like what's called a placeholder, and we've got the variable in there. So what this placeholder means, it just has to match up with the data that it's displaying, okay? So placeholders are percentage followed by a number, or sorry, a letter, sorry. And the letter just tells us what data type it is. So if it's a float, it'll be F. If it was an integer, it would be something else. If it was a different type of data type, it would be a different letter. So this is just a letter that the computer will know, okay, I'm displaying a float value here. The float value I want to display is voltage. And the way I want to display it is all the user is going to see is what's in the quotes, is it's going to be the variable with a 2-point decimal place precision. That's why it's 0.2 there. 2-point variable precision, and then we're going to have V after it. So we're taking what is the value in the voltage memory location, we're displaying it first with 2 decimal points, and then we put V after it to represent volts. So because it's got percentage 1.2F, it knows how to interpret that with voltage, with that voltage variable. It knows it's going to be the data types match up, it's F for a float, it's going to show 2 decimal points, and it will display it. And that's why we see down here, we see, okay, our variable, we see it with 2 decimal points, and then we see a V after it. And that's all we see. So that's just what's called a placeholder. That's how we display a variable in there. If it was a different type, if it was an integer, if it was Boolean or whatever it is, we would have a different, we'd have percentage something different letter to indicate a placeholder. And then if we wanted a different amount of precision, we could have, if we wanted 3 decimal places, we'd have it at 1.3. Okay. So hopefully that makes sense. Couple of new things there, a couple of similar things. So the LCD we should be comfortable with. We've seen a little bit of the analog input before, and then we're just seeing how to display it onto an LCD display using that placeholder type and the precision, the decimal point precision. So again, interlinking a lot of the previous tasks that we've done.